Hello everyone, today we are going to look merge sorting algorithm. So what merge sort do is basically it's divide and conquer. So here we have given an array 3842, and firstly what we have to do is we have to divide it until it is break down into the smallest element possible. So let's suppose if we talk about 3842, then firstly we divide it to 3 and 8, and then we divide it into 3 8. So after dividing it into the smallest element, we cannot divide it further, right? So after doing that, we have to start merging it. And how the merging has done is we have to compare it accordingly, and then we merge it in a form that the formed and the merge list is basically sorted in order. So let's suppose here firstly we have 3 8, right? So we divide it into 3 8 and then 3 and 8. So now 3 is smaller than 8, so we merge it like 3 first and then 8 after that. Similarly here 4 2 got divided as 4 2, then 4 and then 2. Then in the merging time, what we have to consider that 2 comes first before 4. So that is, for any given 2 array, we have to merge it such that the merged array is sorted in order. Now similarly, we can see that now 3 8 and 2 4 are two sorted arrays, so they are sorted. So what we can do is we can now merge both of the sorted arrays. So what we do is, so here let's see an example how we can merge it. So we use two pointers, one is I and other one is j. So I is initially 0 and j is also 0. So what we have to do is we have to compare that here 3 and 2. So in between 3 and 2, 2 is smaller. So that is the pointer j pointing to the element is smaller. So what we do, we append that element first. So 2 is appended here. Now once it's done, the pointer of j changes to j plus 1. So now j points to 4. Now we compare I with j. So now the value of I is smaller than the value of j. So what we do, we append 3. So here 3 is appended. And then the pointer of I increases. So I now points to 8. Now what we do, we compare with I and j. So here the pointer j pointing to 4 and I pointing to 8. So basically 4 is smaller than 8. So we append 4 here. And then here we can see that since there is no further j possible, so we can come out of it. Now we can see that our I is the element I is still left. So what we do, we append it at the end. So this is the approach of merge sort. So firstly we divide it and then we merge it in a form that the final answer is a sorted array. So let's look into the code of it. So here firstly we have a merge sort. So merge sort what basically do is it just uses a left and right pointer, and using this it find out a mid. So in the mid, firstly it calls to the array of the same merge sort algorithm called recursively for array L and mid. So here we can see that here is the left, here is the right, and it is the mid. So first recursive call is for this one, and then second recursive call is for this one. And after that, so basically first is from L to mid, and then the second one is from mid plus 1 to R. And then after doing this, what we have to do is we have to merge it. So a merge function is called. So this is the approach for merge sort. Now let's see how this merge function works. So here merge function is basically working on two sorted arrays, and it actually merges two sorted arrays. So how it does is, firstly let's say we initialize integer n1 and n2. So n1 is basically mid minus 1 plus 1. So basically this is mid minus L plus 1. So it gives the size of the this left array, and this is the right array. So n2 gives the size of the right array. Now we are creating two more temporary arrays in which the size of v1 is n1, that is the left array, and the size of the v2 is n2, that is the right array. Now what we have to do is we have to merge this one. So firstly, before doing that, we have to actually append values inside our v1. So v1 I is equal to array of I plus 1, which actually means that v1 I now becomes the left part of our array, and then v2 I becomes the right part of our array. So here array of mid plus 1 plus I gives all the values in the right side of the array, and it appended already into our v2 array. Now what we do, we use two pointers I and j and we compare. So initially our k is l, and inside our array itself we are going to make changes. So what we do, we firstly check if our v1 I is greater than v2 I. Then what we do, in array of k we have to append v2j, and then we increase the pointer of k and as well as j. And in the same way, if this is not the case, that is v1I is less than v2j, then what we have to do is we have to uh, replace array of k with the v1I value, and then again we increase the pointer. Now after doing that, there may be a possibility that some elements left in our left array or maybe in the right array. So what we have to do is we have to check that case also. So here running a while loop will help. So if the I value not reached till n1, then we do the same thing, that is we append array of k as v1I, and in the same way we increase the counter till the point I is less than n1, and in the same way we can check for j, that is for right array as well. And after doing that, we got our merge sorted array of two given sorted arrays. So here then this merge function got called inside our merge sort, and then after doing that, the whole merge sort will return a sorted array. So let's see with an example. So here n is 5 and I am taking an array 8 to 16 50. So as we can see, it is not sorted. So what we do, we call a merge sort. So since merge sort as well as the merge function is a void, so we it doesn't have any return type, so we just have to call it and all the changes will occur here. So here once we call merge sort for the array arr, it will automatically got sorted. So now we are trying to print the elements of arr. So what we do, let's try to run this code. So here you can see that the elements of ARR are now in sorted form. So this is the approach to solve a sorting problem of a merge sort, or the process of how merge sort actually works. So if you want to access the code, then you can check the GitHub link given in the description. And this is it for this video. Thanks for watching.